Solving quadratic equations by completing the square. Okay, well here's what we've seen so far. If we have a quadratic equation, if we can factor, then we can solve. We take our quadratic equation, we factor it, we get our two answers. Or if our quadratic equation happens to be in the form of having a perfect square, we can use the square root method. We do square roots on both sides and we can solve. So what we're going to deal with in this section is equations like this. And what happens with this one is, first off, it does not factor, and second off, it's not in the form of a perfect square. So what we're going to do is a technique called completing the square, which means we're going to take this left-hand side and we're going to write it in terms of a perfect square. So here's how this is going to look. You're going to rewrite this equation as x squared plus 6x equals -7. So I subtracted 7 on both sides. Then you're going to add just the right number to both sides to make it so the left-hand side is a perfect square. For this equation, just the right number happens to be 9. And in just a minute here, I'll tell you how I got that number. But first I want you to get the overall idea of what's happening here. What we've done now is we've written the left-hand side so that it will factor, and it factors in a very special way. It factors as x plus 3 times x plus 3, or I'm going to write that as x plus 3 squared. On the right-hand side, we add our like terms. So do you see what we've done? We took an equation that was not a perfect square, and we wrote it so that we do have a perfect square. That allows us to do what we did last time, which is take the square root on both sides. And then, square root on both sides. And then once we have done the square root on both sides, we can solve easily. Okay, so that's the general idea. The general idea is we're going to start with an equation which does not factor and is not written in the form that allows us to use the square root method. And we're going to do a little bit of work, and we're going to rewrite it in a form that does allow us to use the square root method. And here's how I got that magic number. Here's how I came up with 9. Consider if I just had x plus c squared, because that's what I want ultimately. Ultimately, I want my equation to look like that. I'm going to just go ahead and I'm going to FOIL this out. I'm going to take x plus c times x plus c, and I get x squared plus 2cx plus c squared, because I have x squared and then I have a cx on the outside and a cx on the inside. That gives me 2cx. So notice that the number b is 2 times whatever this original number c was. So if I know the b number, which is what I knew up here I knew the b number. If I know the b number, the c number is b over 2, but I don't really want c back up here. I really want the c squared. So c squared is b over 2 squared. So here's how I got this number 9. To get this number 9, that was the special number to add to both sides. I took 6, I divided it by 2, and then I squared it. So that turned out to be 3 squared, which was 9. Alright, so let me do a couple more examples for you here. Solve. X squared minus 4x minus 1 equals 0. Alright, well once again, I could try to factor this equation. I would be convinced very quickly that it doesn't factor, so I can't solve that way. I notice my left-hand side is not a perfect square. So basically I'm going to fix it. Again, the technique is we write x squared minus 4x equals 1. We add the 1 to both sides. And then I got to add just the right special number to both sides, the magic number. To find the magic number, I take this number in the middle, -4. I divide it by 2, and then I square it. That's negative 2 squared. That's the number 4. Alright, so I'm going to rewrite this. This is x squared minus 4x. I'm going to add 4. And when I add 4, of course, I have to do it on both sides. If I've done it right, this left-hand side should now factor. And you can check it. It does. It factors as x minus 2 squared. And then over here we have number 5. I can now do my square root on both sides. And then finally, to get x all by itself, add the 2. Alright, one more of these and then we'll talk about how this gets harder. How about x squared plus 8x plus 3 equals 0. Again, when I see a quadratic equation, the first thing I look at is, can I factor? And immediately that one I'm convinced I can't factor. And once again, I see that it doesn't fit into the square root method yet, so we're going to fix it. So we're going to write x squared plus 8x equals negative 3. Then we're going to find the magic number. To find the magic number, we take 8, we divide it by 2, and then we square it. 8 divided by 2 is 4. 4 squared is 16. So that's going to give me x squared plus 8x plus 16 equals negative 3 plus 16. Left-hand side factors perfectly as x plus 4 squared. And over there we have 13. And then from there, they're all the same. We do square roots on both sides. And then we subtract the 4. Okay, so how do these get a little bit harder? Well, you might notice that all the examples I've done so far, I've made it so that this number in the middle is even. And that's a nice thing. And the reason it's a nice thing is when you go to find your magic number, when you divide by 2, it comes out evenly. So the way these can get a little bit harder is to have that number in the middle not be even. So let's say I wrote x squared plus 7x minus 2 equals 0. Again, unfortunately, it does not factor. I add the 2 over. And then I have to find my magic number. My magic number is going to be 7 divided by 2, and then I have to square it. And like I say, 7 divided by 2 doesn't come out nice, so I'm just going to write this as 49 over 4. So I have to add 49 over 4 to both sides. Okay, now if I've done it right, this left-hand side should factor. It's got to be an x here. It's going to be a plus because that's a plus in the middle. But what's the number that goes right there? Well, if you look back on these examples, I think it'll help. Notice that I ended up with a minus 2 right there, and I had a minus 2 right there right before I did the squaring. On this problem, I ended up with a plus 4. And notice that I had a 4 right there, right before I did the squaring. So what happens? The number that goes here is the number that's right there, right before you did the squaring. So it has to be 7/2. And over here, we write that as 8/2, so that's 57 over 4. I square root both sides. And then I subtract the 7/2, and I would write x equals minus 7/2 plus or minus the square root of 57 over 2. Notice the square root of 4 down on bottom is 2. And we could even do this. We have common denominators there, so quite often we write our answer this way, negative 7 plus or minus square root of 57 over 2. Can't quite see that. There it is. Okay? Okay, so here's your first batch of homework problems for this section. I want you to solve the following 4 problems by completing the square. Now, the first one is one that does factor. You can solve it by factoring. I just wanted to show you that you can also solve by completing the square, and you should get the same answer. So that's something you might want to check. You should be able to factor that one very quickly and get the right answer. The other four, these do not factor, so don't waste your time trying. But all three of the last ones can be solved by completing the square.